In this lecture, we are going to import and inspect the movies dataset containing 45,000 movies that were released between 1874 and the mid of 2017. And first of all, we need to import some packages and libraries that we not only will need in this lecture, but also in the next videos. So we import pandas, matplotlib.py.splt, and also numpy. And then we set the maximum number of displayed columns to 30. So the default setting is 20. And actually our data set or data frame contains more than 20 columns. So we set this to 30 to get all columns or to see all columns. And finally, we define that floats should have 2 decimals. Then we import the movies dataset from the CSV file movies complete.csv. And again, this is only possible because the Jupyter Notebook we are coding in and the CSV file are in the very same location or folder. And finally, we have one column with datetime information, release date. And here we convert the strings to the data type datetime by passing the column to the pass dates parameter. So let's import the data set and let's create a data frame, and let's save the data frame in the variable df. And let's have a very first look at df. So each row is one movie, for instance, Toy Story, the very first movie that was released in 1995. And actually the very first column here on the left-hand side is the ID column. And this is a clear identifier, or to say the primary key, which uniquely identifies a row or a movie. So these are unique values, and there are no 2 movies that share the very same ID. Then we have, of course, the title, then the genres, and whether the movie belongs to a collection or not. So here it's the Toy Story collection. Then we have the original language, which is here English, then the budget, and many more features. So we can scroll here to the right. And here we have more features like the cast size, or the director, and spoken languages. And finally, it definitely makes sense to call the info method to get some meta information on our data frame. So in total, we have 44,691 movies or rows. And in total, we have 22 columns. And here we have the column labels, and we can see that we have quite a few missing values. So for instance, in the belongs to collection column or in the revenue column, we have many missing values, but this is okay. So it depends on our analysis, but generally speaking, there's no need to handle or remove or fill missing values, because Pandas is designed to handle missing values. And finally, here on the right-hand side, we have the data types in the columns. So we have numerical columns like ID or budget and revenue in $1 million US. And here below we have a summary. So we have one column with datetime information. Then in total we have 9 numerical columns and 12 columns with strings or text data. And the total memory usage is 7.5 megabyte. Next, here we have a list with all columns and a short description. And we won't go through all of them now, so feel free to have a more closer look on your own. And for instance, we have the column genre, and these are the genres associated with the movie. And we can go into the second movie, for instance, it's Jumanji. And here we can actually slice our index for the element here in the genre column. And already here we can see that a movie can belong to more than just one genre. So we have adventure, fantasy, and family. So let's have a look here. And here we can see that this is a string with in total 3 genres. And these are separated by a pipe symbol. So we will see later that it is pretty easy to extract the single genres from this string. So that's what we will do later. And the same we have in the cast column. So let's have a look at the cast or the actors of Jumanji. So for instance, here we have Robin Williams. And also here we have a string with many actors separated by a pipe symbol. Next, it is always helpful to get some summary statistics for the numerical columns with the describe method. So for instance, here we have the movie budget in million US dollar, and the mean budget is 21 million, and the most expensive movie has a budget of 380 million. And also we can visualize the frequency distributions in these columns with a histogram. So we have here df.hist, and we want to have a figure size of 2012, and in total we want to have 100 bins. So let's have a look here. And here we get a matrix with our numerical features, and for each and every feature we have here the histogram. And for instance, here in the budget, we can see that most movies have a budget between, let's say, 0 and 10 million, but there are quite some heavy outliers here on the right-hand side. So we have seen the maximum budget is 380. And also most of the other features are right-skewed with extreme values on the right-hand side. So there is actually very few movies with a cast size of greater than 300. Then we have crew size, popularity, revenue in million US dollar, and we have the vote average. And here we have an interval between 0 and 10. So 0 is the worst vote and 10 the best vote. So this is the rating by the audience, and it's an indication of the quality of the movie. And finally, here on the left-hand side, we can see the distribution of the runtime. So typically a movie has a runtime between 1.5 and 2.5 hours, but also here there are some outliers. And to clarify, the runtime is in minutes, so the most frequent runtimes are 90 or 100 minutes. And we can further analyze single features, for instance, the budget with value counts. So we could get the 20 most frequent values with a combination of value counts and the head method. And we include missing values by passing false to the drop-in-a method. So in total for 35,000 movies, we don't know the budget. Then the most frequent values are 5 million, 10 million, 20 million. And the same we can also do for the revenue. And also here we have quite a lot missing values, so over 37,000. And the most frequent values are 12, 11, 10, 2, and so on. And we can also have a closer look at the vote average column. So that's the average rating of the movie. And also here we have missing values, and the most frequent value is 6. Next, let's have a look at the number of votes or ratings. So there are many movies with only 1 rating. And finally, we can also get some summary statistics on non-numerical columns containing text or string data with the describe method by passing object to the include parameter. So here we have the non-numerical columns, and for instance, we can have a look here at title, and in total we have over 44,000 non-missing values, and we have 41,000 unique values, and that means that we have duplicates. So there are some movies sharing the very same title, and the most frequent value or title is Cinderella with 11 occurrences. And we can actually filter our data frame for all movies with the title Cinderella, and we should check whether these are real duplicates or not. And let's have a look here. So here we have the first Cinderella movie that was released in 1950. Then we have the next one created in 1997 and so on. So it seems that these are different movies with the same title. All right, this was the very first inspection, and see you also in the next lecture. Bye.